Today I want to talk to you about jumpstarting your serverless journey. This is a topic that I've been doing the last 5 years and I really love to do. But it's a beginner's talk, so if you have a lot of experience, yeah, he has a lot of experience with serverless. No, okay. So yeah, if you have a lot of experience with serverless, I might not learn you a lot today, but if you want to enjoy my lovely voice, maybe at the end you will be able to win something, because we're going to be a little game. I've got some gifts for you, but that's for the end. So today we're going to talk about serverless within AWS, to have different other clouds, but AWS being the cloud that I've been using the most, so I feel comfortable with AWS, but the concept remains the same. So you can probably use it also in the other clouds. And for the TypeScript part, well, I'm doing TypeScript, so if you're doing another language, there's enough AI tools out there that you can use to just, change it. So, serverless. What is it, serverless? Let me try to explain that with a simple example. I don't know how many developers do we have here? Well, okay, a lot. So you're all Kung Fu, almost maybe Kung Fu masters in what you do, and you probably like to do development. But before you can do development, or before you can do Kung Fu, you need a place to do it. So if you want to do Kung Fu, you have to build a dojo. You will be hammering woods, you will be cleaning the floors, you will be doing a lot of different things before you can do Kung Fu. And that is what I feel when I do Kung Fu in the development world, happens when I do it with traditional development. Of course, you can have a big team, you can have a SRE team that does this all for you, but then it costs also money. And yeah, if you're alone and you want to do Kung Fu, you have to do a lot of things yourself. Now imagine that you want to do Kung Fu with serverless. Well, this is how I feel when I do Kung Fu with serverless.
I know Kung Fu.
Indeed. So like, I hope you saw the Matrix movie. Who didn't see the Matrix movie? Okay. Maybe. But yeah, so Neo gets connected and they just upload the Kung Fu, and then within the Matrix, everything is happening for him, and he can just do his Kung Fu. And that is what you do with serverless. You can just focus on your development. That's what you want to do, that's what you like to do. You don't want to manage a lot of different things. But yeah, that's not the only thing. Indeed, you can focus on development. There are other stuff that are cool about serverless. So yeah, it's cool. So this, by the way, that's my frenemy. So that's my dog. I don't know if anybody has a Frenchie here. If you don't ever get one. Cool dogs. But they never agree with you. They never agree with you. But just today, he agrees with me that it's cool. You know why he thinks that it's cool? Because he's lazy. And like with serverless, he only eats, sleeps, snores, and the other smelly thing also. And I'm basically the cloud for him. I do everything for him. I have to get him out. And that's why he loves serverless. No. More seriously, serverless is cool because you have zero server maintenance. You just don't have to maintain your server, anything. You don't have to do anything. So you can just be lazy on that part. So that's pretty cool. So when you are developing things, you are deploying things on the cloud, and you're all developers, you never write bugs, right? You deploy everything correctly. You can just chill like this, AI girl, and enjoy the application as running. You can go sleep, everything will run smoothly. Another cool thing is that it will auto-scale. It just works out of the box. Of course, you will have to write your code in a way that your code it can scale, but the infrastructure behind it works. Now, I like this image a lot because it can also get out of hands, right? You put 2 rabbits in a room, you can have a lot of rabbits. So you will, at some point, take care of that. But I also want for today to just think about the happy path. Again, we're developers, we only love to do happy path stuff, right? Okay. Another one that's cool is pay-per-use. When you're doing serverless, real serverless things, you will only pay for what you use. So if your application is not being used, you will just not pay for it. And chances are, even in AWS, you have like 3 tiers. And if you're starting with serverless, chances are that even you won't pay anything for it. So that's also a very nice thing for development environments, for example. And so having all this means that you will be faster at development because you can focus on development and you don't have to worry about all the infrastructure. It's also everything that you have in AWS with serverless is all event-driven, so everything is connected with events. You can listen on things, so that's pretty cool. So a couple of use cases where you want to use serverless is like you want to build an application that has unpredictable or spiky traffic. That's something that can be very useful to use serverless because something can happen at one part of the day, and then you don't have to do anything with that service. It's just going to work. If you're a startup, you just want to focus on your ID. You don't want to think about all those servers, all those things. You just want to focus on the ID. You want to be able to switch fast and things like that. And also, it's a startup, so you don't know how it's going to work. You don't know how the server is going to be handled. So very good use case also. Already talked about the event-driven workloads. Also, it's not because you're doing something not serverless that you cannot use serverless services in AWS. So there might be something that could be very useful with serverless and something that is not useful with serverless. And then cost optimized, so already discussed about the dev environments, but also if you have a lot of idle periods and things like that, you just won't pay for it. Use cases maybe where you want to avoid serverless is there are some limitations. You have maybe long-running services that you want to use. There are some servers that we'll see, like for example Lambda, have limitations. And that cannot be a good solution then. So you all have to look at that. So if you have to run things 24/7, might not be the good solution to your problem. Latency-sensitive applications. When you're doing serverless, you will hear and maybe heard about cold starts. That is something that you will have to know about. You can solve that. You can write your code in such a way that you can limit the cold starts. But you will have to learn about that, and you will have to take that into account. Then, strict compliancy, that's maybe for the cloud in general. I'm not going to too deep into that, but if you have strict compliance rules from your customer or your company, it's maybe something that you have to take into account also. And then, last but not least, portability challenges. If you use the cloud, even general, not even just serverless, but doing serverless might put that vendor lock even deeper. So if you're, imagine a junior developer, you will have to be careful that you disconnect or decouple your code, that you're not too connected to some of the infrastructure behind it. But up to a certain point, you will at some point use maybe a serverless service that will hook you or at least put that vendor lock deeper with AWS. Okay, so that's a lot of theory. But I had the chance in the last 5 years to work on 3 amazing serverless projects. The one was 5 years ago, the Contents Exchange. And that is basically a web application that integrates data from different publishers, and they put all the publishers on one platform, and some publishers can buy the content from another publisher and things like that. It was a startup. They wanted to start within the 3 months, have something up and running, and we were like a couple of developers. And today, 5 years later, it's a lot of things did change, but there are some API things that we have built and are still running today. 5 years later, and we didn't change anything, except, of course, upgrading your code and things like that. But on the server or in the infrastructure, we didn't change anything. And they have now more than 20 million content, and they increased all the customers. And there is one single developer today at that company. So that's pretty amazing that they can continue that service. Then I started working for client GLS Belgium, and they came to us and they had AS400 with DB2 and things like that, you know, the servers that are older than me. And then they said, yeah, we want to do digital transformation and we want to be in the cloud. Okay. And then we need Kubernetes and we need this and we need that and all the big stuff and the big names, and I was alone. I said, no, I'm not going to do that. And we started serverless. We started with very simple things. It's not fully serverless. There's a Kafka stuff into there, but all the consuming from Kafka was all serverless. And it's GLS, and I don't want to hear complaints about GLS, yeah, you have, if you know a little bit in the logistics sector, every morning you have all the drivers, like really hundreds of drivers, all scanning those packages. So you really have those spike in the morning. And our system just, yeah, with server, it just worked. And then we went Black Friday, Christmas, you know, the load, it's like 4 or 5 times higher and no issue. So yeah, that was pretty cool. And now, since a couple of weeks ago, I started helping another customer, the Anything. And this is also pretty cool because this is, we're in a cinema here, and they've built an application where you can watch cinema like in a hotel, for example. They have a private room for 2, 3, or 4 people, and then you can just watch cinema from your mobile phone. They have a real professional installation. You can order food, you can do a lot of things, and let's say 95% behind it is serverless. And all 3 had that combined thing that it was very few developers, no sysops, nothing of that. And we could sleep at night. So that's really, really, really powerful. So what are all the services out there for AWS? I tried to make an image with everything on it, but actually I didn't have enough space because there were much more than I thought. A couple of them are not 100% serverless, like the RDS, for example. I don't know if you know RDS, but so there are some services where they take the name and they put serverless behind it. But the idea of serverless is that you only pay for what you use, but there are some services that no matter that you use it or not, you will pay for it. But the serverless is like the scalability, for example, that it can really, you have a small instance and then it can scale automatically to something bigger and then you will pay more and things like that. But all right, you have different categories. You have compute, application integration, storage, analytics, network, secure. Basically, you have everything that you need to make very complex applications. Okay, so again, he doesn't agree with me. But yes, you will still be faster. You don't have to trust this one. But it's true, if you want to do serverless, you will have to know or understand the concept, but you also will have to know your clouds. Although there are some applications, and we'll see them a bit later, that can help you abstract away a bit the complexity of the cloud, and then you have also some good people that are doing things like Mathieu Napoli, that's here today, that is building the Brev Cloud and try to abstract away the complexity of AWS serverless, and that's serverless with PHP then. But still, you will have to understand a bit the cloud where you wanna work or where you wanna deploy your serverless. So, just let's focus today on those 4. Basically, those 3. The stream is something from DynamoDB. It's API Gateway, Lambda, DynamoDB, and then the stream. So API Gateway is just a full-blown REST API service. It can also do other things, but if you want to make a REST API, you just want to use API Gateway. It's fully serverless. So basically, there are no servers. And it can trigger any services behind it. So in this case, we're going to talk about Lambda. But yeah, if you need an API and you need all the fancy things of a REST API, whether it's caching, throttling, quotas, auto-scaling, it just has it. It can also authenticate with serverless services that you have in AWS, which is Cognito. Not going to go into there, but if you need an authorization, an authentication system, full-blown, with OAuth and things like that, you can just use that and hook it very easily with API Gateway. You don't even have to understand how all those things work. It just does it for you. Then we have the Lambda. So that is basically something that allows you to run code without servers or without managing servers. And it has multiple runtimes. So I'm doing it with TypeScript, but I mean, pick whatever language you like that is supported on Lambda and go with it. It just works. You can even mix things. That's also a good thing. Imagine that you have to do something very specific and it only works in the Python world. You can do it. Again, pay-per-use, event-driven. It scales automatically. And didn't put it, but it's also really not expensive. And that's it. So if in code, you like to see code, I guess. But that is basically a function. So it gets an event, and it will expect a response. And then if you use TypeScript, you have like those typing API Gateway proxy handlers. So you're telling to TypeScript that, hey, this function will be called by API Gateway, and then it will give you all the typings from what you can expect in this event and what you have to return. That's basically what you have to run. And with the tools we'll see later, this will automatically be connected with all the services behind it. Like with everything, there are limitations, there are challenges. We said that long-running processes, that's not going to work with serverless, and it says Lambda. A Lambda can only run for 50 minutes. But yeah, think about it. You're making a simple application or a complex API application. Lambda that doesn't return in 50 minutes. Not sure that your end user will want to use your API. So those limits are there, and you will have issues at some point where we'll do some fancy things. So you have to take that into account. Talked about the cold starts. That is also, so it's a Lambda. There is no server, so that means that you have code that is packaged, and on the moment that you need your Lambda, it will have to get warm. So AWS will get your code, will put it on a server if we want, extract that file, and have to run it. So the first time that you run it, that's what we call that cold start. And you can limit that. You can make sure that your code or your package is as small as possible so that you minimize that. You can keep them warm also, but then it costs money because then you get a bit away from the serverless part. But so yeah, you have to take that into account. But chances are that even in the beginning, you won't really notice that. And also, if you have a website that has regular visitor, you also won't notice that because a Lambda will stay warm after for like 2, 3, 4 minutes. So if within that time that somebody else asks a request, it will already be warm. And you won't pay for that warm part. That's pretty okay. Because I saw already a project that said, yeah, we need to do a Lambda lit. And that's a Lambda lit. It's like putting everything in one Lambda, package everything, and it can do everything. And then it's big. But actually, you need to wait that you have a bit of load to your application. And then there's limited ephemeral also. But again, this is something that you're doing something very fancy. I mean, let's assume here you're making an API gateway. Chances are you don't need more than 10 gigabytes of data. Okay, DynamoDB. That is, it's a fully managed serverless NoSQL service, basic key value documents, or MongoDB equivalent if you want. I'm not going to say that you have to use DynamoDB in that sense that if you have relational data, don't use NoSQL. I mean, use a relational database. But if you have something where you have key value or there are ways to put relational data-ish into DynamoDB. There are a lot of talks about that, so you can look at it. But again, don't misuse that. But if you need key value, I mean, DynamoDB is pretty amazing. It scales impressively, has big response time, high available on-demand pricing again. So you only pay for what you use. So that's pretty cool. So if you don't use it, just pay nothing. And then it has also something that I find pretty cool is streams. So that's basically a change data capture system. So everything that happens on DynamoDB, you can just have a stream on it, and then you see everything that changed, what was the previous value, the new value, and then you can do something with it. So imagine that you have a document store and then you need to go to Elasticsearch, for example. You can just almost do that immediately. Again, challenges, DynamoDB, if you are used to work with MySQL, Postgres, MariaDB, you will have a hard time with DynamoDB in the beginning because you will want to normalize your structure and things like that. It's not going to work. You have to think about the reads, the access use cases. How am I going to get the data out of DynamoDB? And that is really, really important with DynamoDB. But if you do that correctly, then you will have those amazing performances. One thing that is also good to know, and I learned that the hard way, is that writes are expensive. It's like 4 or 5 times more expensive than a read. So don't do like me, like the equivalent, like in MySQL insert or update thing, and like with the content exchange, we get data from RSS feeds, and we just write. At some point, it was like, ooh, we have a very big cost on DynamoDB. And then we started just to say, okay, let's read from DynamoDB. Let's check if there is a change. If there is a change, we write, and then not, and we like, the price went down by 10 times or something like that. So that is that is something also good to know. And then there's that limitation of 1 megabyte. When you are used with relational DB, you say like, I want to have a select star from, and then you say I want to have record 1 to 50. Well, with DynamoDB, it might not that you get the 50, because if your result is more than 1 megabyte, you will maybe only have the 23 return. So that is something also that you have to know if you have a lot of data in those records. Okay, so we talked about the first things, Lambda, API Gateway, DynamoDB. But how do we put that into the cloud? I mean, AWS, you could use the console of AWS, but I don't, you should not do that. You should really put everything as code. That's way better. But so there are orchestration tools that are available. There are even a lot of orchestration tools available. I only knew a couple of them, but yeah, there seems to be really a lot. I didn't even know this one, Zappa. So I don't know if there are Python developers out here. One, okay. But this seems to be written in Python. So yeah, didn't know about that. But I would say that the two most famous one today would be Serverless Framework and CDK. So if you want to get started with Serverless, yeah, I would say to start with Serverless Framework. But I've been doing now CDK for the last couple of weeks, and it's start to like it also. But if you're really starting with it, what I like with Serverless Framework is that it's easier to start with it because it abstracts away a little bit of the complexity of AWS, while with CDK, you already have to know a lot about AWS. If you use CloudFormation in the past, for example, it's almost a copy-paste of CloudFormation. But then they changed some names because CDK is newer than CloudFormation, and yeah, I had some hard time in the beginning to match it. While Serverless Framework, yeah, for me it's easier. There's also you can see it as an advantage or the opposite, but it has a YAML language, and maybe you say, oh yeah, yet another YAML language. But there is one thing that I like about that is that it allows you to keep the infrastructure part away from the application part. With CDK, you tend to see that it gets mixed sometimes, that you are mixing application with infrastructure. That is something that I would not suggest to do. But with Serverless Framework, there's also a plugin to do it with TypeScript if you want. Serverless Framework is also not from AWS, so it will be, the version 3 was able to go also to other clouds. With the V4, they ditched it, and then they will get back to it, and they said that they will also allow you to go to other clouds. So that might be a good solution if your company has, that rule that it needs to be able to go to different clouds. So, okay. But what might be blocking is maybe the commercial aspect, because since Serverless V4, it has a licensing. So if you earn more than 2 million, you will have to pay. CDK, you will not pay. So if you're only into AWS, and you're not afraid and you know already about AWS, you might start with CDK. Just to give a quick example of the differences between serverless framework and CDK, if you want to start with it. On the left, you have serverless framework. So you see already that you have to provide the provider. So that remains, so that if tomorrow they want to go to Google Cloud or Azure, it's there. So you'd say, I want to have AWS, have Node.js, the region. And then you say, I want to have a function, the name of the function, where the code is of that handler, and on which event it needs to trigger. So here I say I need to have an API that triggers on the root. It's a get method, and just call this handler and the code that's in there. You compile it, it does serverless framework, does everything for you. It's going to orchestrate that in AWS, and all the complexity of IAM permissions and things like that will all be handled by serverless framework. And then on the right side, you have the CDK flavor. If you really look at it, it's not that much more complex. It's maybe a little bit more verbose. Now, I'm not gonna lie, this is really easy application. So if you get a very complex application, even with serverless framework, it will also be verbose at some point. But it has, one of the advantages is that it has its own language. So here on the right side, it's just code. So you can structure your code the way you see fit. So, but with serverless framework, you have to follow a structure. It has an API spec behind it for this YAML. So if you saw a serverless framework application, you will probably understand how another application works. While with the CDK, if somebody is doing messy stuff, you might have a harder time to understand how it all works. Okay. So I want to play a game with you, because when I was preparing that talk, I was like, it would be cool to show the power of serverless. So I was starting to build a little game. Yeah, that game, I called it the Battle of the Attendee. I don't want you to start fighting, let's that be clear. But the idea was that with your mobile phone, you can scan a QR code, you get a form, can put the seat number with the alias, because I learned yesterday at midnight that not all the seats had a unique number. And I want to be able to send as many requests as you have. And I'm happy that I don't have 5 people in the room, because otherwise there's no point in testing the scalability of Server with 5 persons. But if everybody plays the game, we might see something. And you can win a prize. Huh? So you have, everybody saw Back to the Future, right? Yeah. Okay, so I have Doc with the helmet. That's the first prize. And if you're second or third, you have a free drink for the after party. That's the perks of being at working at to be the organizer. So we have a mobile phone. You will trigger an attack on API gateway. This will trigger a Lambda, and that Lambda will store in DynamoDB. And I want to store that as fast as possible. So that means that I see already phones ready for. By the way, I blocked on the Lambda, so I have to change a variable. So even if you start already clicking, it's not going to work. So we'll have to say 1, 2, 3. But yeah, so I have a Lambda that will be able to store into DynamoDB. And I want to have it as fast as possible. So that means that I see the attack request or the attack. I see attack as an aggregate. I don't know if somebody here or if you're a bit acquainted with domain-driven design, but I just store that attack as an entity into DynamoDB very quickly. Then I want to aggregate all the same attacks to know how many attacks did I have. And I want to do that asynchronously. And there are many ways you can do that with serverless, because I didn't want to make too complex. We could have used Event Bridge. We could have used a lot of things. So here I keep it very simple. Store it in DynamoDB. And then I use the power of that stream part. And this will trigger a Lambda that will handle the data coming here. It's just going to aggregate all the attacks that you have and just write it again in another record in DynamoDB. And that the other API call that the application will use is to just get the top 10 of the ranking and show it here on the screen. So you will be able to click on the screen, you will see the ranking, and so you will be busy like this. Okay, 32 minutes, what time is it? 14:40. So you can choose. Either we go and look a bit at the code, or we play the game. Okay, of course. All right. So you can prepare this one. No worries. Wait. I think I will have to stop this one. Is it gone now? Okay. Does it work? No, wait. I just, I don't know why. Wait, let me get out of this here. Let me do this, just putting this here. Okay, I can already put this here. Oh, didn't I clean the database? Oh my. Okay, we'll have to clean the database. Wait. Logging in. I thought I cleaned it. It seems not. Okay. Oh no, did not clean it. Okay. Not yet. Not yet. Or did I forget to close to? That's possible. Let me see. So maybe you're cheating already. Okay. Indeed, it's open. Yep. No, I'm not. Okay, I closed it. Sorry, I have to delete everything. I hope you didn't send really like million requests now, because otherwise, damn. Okay. Didn't prepare that enough. Okay, duly noted. Demo effect, sorry. Another inconvenience of DynamoDB is that you cannot just do delete star. You see, so I have to do delete by 300 records. And it seems that you really want to play. Yeah. And it scales. Okay. Come on. How many requests did you send?
You are going to count down now. 3, 2, 1, and then.
Oh, okay. Okay. Actually, I can do it differently. Let me do quickly. Let's do this. Okay. All right, I'm gonna open it. So I suggest you put either a unique alias or your seat number, unique alias. And you cannot cheat, basically, because I tested it with colleagues yesterday, and they said that you can cheat. So I added a unique number. You will see the unique number on the, so you will have to show me that. Otherwise, you were able to cheat. Okay, I opened it again now. I'm not sure if it's gonna work. Okay. So seats, what is it, S3, row 4, 83? No.
That's not correct. It's not possible.
So I'm gonna close it soon, if it's okay for you. I closed it. Who won? Who? You? First? Row 4, yes. Melvin, that one, that name I know. Still running? Seriously? I know. It's really not running, or it's throttling. Maybe you killed it. You killed it. I do see like 290 requests. It's still going up. Yeah, but that's just probably. But it's not gonna. But the thing is, it is running, but the stream is probably still busy. By the way, I'm gonna show this here. But actually, it would be better if I do it like this. I think. Whoa. Where is it? Here, like this. Was it? Yeah. So what we see here in the last, let's say, last 15 minutes. Okay. So what we see here is that we had like, in a couple of this time, like 7,000 invocations. And it's used up to, at some point, up to, what is it? 66 lambda, different lambdas. So I wrote one very simple application, and it was just able to accept all the attacks that you sent with a lot of invocations, but it only used 66 lambda. So there you see that a lambda is being reused. So it didn't execute 7K lambdas behind it, because you use a lambda, then it's idle again, and another request is being used. Is it still going up? Do I have to replay, or where is it? Yeah, wait, I lost the lost in translate. Where is the game? Okay. Did I close it? No. Is it here? Okay. Let me just go to the to this part. I didn't deploy this one, so I just need to open that one. Okay. I don't think it's. I know it's mirroring. Okay. So this is the end result. So who did win? Be earning. Okay. You're the first prize. Okay. You're the second. And who's? Ah, hey, okay. Then we'll go to the, we have Elias there, and then Melvin doesn't take it. It's 7-3 DJ. Okay, congrats. Big applause to you. There you go. For the after party. All right. So I'm pretty happy that you didn't, that it didn't break it. Okay, let's see, how many time do I have here? Still, it's until when? 55, okay, I can show some code. You want to see some code? I'm not going to show you this one, I generated that with AI. I'm a backend developer, don't ask me anything about the front end. So yeah, serverless. Just going to show first this one. So we have 3 functions. We have the attack function, which gets the name of the DynamoDB that we need to call. Just a very simple variable that allows me to check is it enabled or not. The code where this handler resides in my application, and then this is an event that is the API gateway telling that I need to listen on the HTTP event, and it has to listen on the /attacks with a post, and then you have the core. So if you were at the keynote of Kaneko, you have to enable the core because I'm running it from a different domain and things like that. So you need to enable that. And I have another function in the same way, except that here it's another URL, it's another method, and it's also another handler. And then in the same way, we have yet another function. I give it the maximum timeout because it's a stream, and I tell him that you can go to 15 minutes if you need to, because otherwise you have a default timeout of 6 seconds, I think it is, and then it will just cut your application. And I tell him, don't be triggered by HTTP call, but be triggered by a stream of type DynamoDB. You have different kinds of stream in AWS, and I just give him the stream RNN, which is something typical of AWS. Maybe I can show the ugly part here also, is that if you want to create DynamoDB within serverless framework, you can just with YAML, you can also link a file to make it a bit less big here. But you will end up doing CloudFormation. So that is something that might be, you might not like it, but you can do it. What you can also do is for all the, what I call the stateful part, so a database and all those things, you can also use Terraform in a different repository if you want. So you can build all those things that you want, that you find important, that you don't want to lose and things like that, to put it in a Terraform or any tool that you like, or any infrastructure as code that you like. But you can just do it also in serverless framework. And this is basically saying that I have 2 columns with a partition key and a sort key. But yeah, I'm not going to explain all this because it's I can talk an hour about DynamoDB. But so this is how we create that using CloudFormation code. And if I go, and also this is also something that I like to do, is that I like to organize my code with application layer, domain layer, infrastructure layer. So everything that is related to infrastructure, like a Lambda, I just put it here, and then this is a matter of taste, but then I put it under the HTTP, and I have an attack code. And this is, maybe it's a bit, can I do it like this, still readable? Yeah. This is basically the code. So it will receive that event, you can log it. I check the environment, that's just a little function that just do the process.env and can return a default value. If it's not true, I just return a forbidden. Otherwise, I parse the payload that I get in the body, just using Zod, probably know that. And then I use just an application handler. So if you see here in that Lambda, I only put logic that is happening in AWS, so validating some data coming in, but everything that's application logic, I put it outside of that, so that if I want to call it from somewhere else than Lambda, I don't have to change all that application logic. And in an application, there's not a lot here. I just register attack, so I just make an attack, so it's a function that gets from the seed, gets something, and then it saves it in DynamoDB. And that's maybe something that we can quickly look at the code of DynamoDB. That's basically it. It's a very easy put command where you have to follow, you have to read a bit about the partition key and sort key, and then all those values that you put after, you can put whatever you want. This is just key value, just put anything and DynamoDB will read it. But you know, the thing that I said about the reading use case, this is something that you will have to read about before you can decide on how to structure this thing. And then the stream, so we call the projection. Maybe I need to go first to the stream part. Basically, this is more complex. First of all, you will get the types of event in DynamoDB, because it can also be an update or delete. So here I'm only interested in inserts. You can also check some things that are present, and then you have that marshalling thingy complex part, because Dynamo stores it in a different way. So I have to do some fancy thing here to just have, you know, a clean JavaScript object. And once you do that, Well, again, I validate all those things. I verify that it's an attack. And then again, I'm calling just an application part to process that attack. And in the process attack, I'm just doing, and where is it? Here, the projection. And here I'm doing something that might not be the most or the best way to do it, but I'm using a transaction. At least you see that you can use transactions in DynamoDB, but it has also a downside. That's also why I didn't want to do that on the first call, is that if you're doing a transaction and you have like thousands of requests coming at the same time, well, what do you have with MySQL, for example? You will have deadlock kind of things. And you will have that also here. It's not called deadlock, it's called condition. No, it's not this one. It's transaction canceled exception. And what am I doing? I'm just saying that, okay, if that happens, this is very simple. I'll just say wait 5 seconds. You can do that much better. But I just wait and retry. It's the same with the transactions issues that you can have in MySQL. Either it's a smell in your code, that's also possible, but it can so happen that you have so many data that you just will have that issue. And then you can solve that like this. You can also solve it in other ways. You know, with serverless, you will have to think a bit, but it's because it's not really an issue of serverless, it's an issue of scalability. Once you have a lot of data, well, you have to manage that. So that's something you have to think about. We're out of time, but I'm actually finished because just have one slide left. Why am I at the end? Okay. Very important one. Thank you.